Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the following problem. We want to find the minimum value of square root of x squared minus 6x plus 13 plus square root of x squared plus y squared plus square root of y squared minus 8y plus 17. Here x and y can have real values. And the thing is, this is not a complicated calculus problem, but rather a geometry problem. This means that we have to interpret this expression geometrically. Let's see how we can do that. Let us denote our function as fx, y, because both x and y are input variables. Here we are going to use the trick called completing the square, which changes our expression into, for the first part, we write the complete square x minus 3 squared, and in order to make constant term 13, we need plus 4. And for the second part, we just write square root of x squared plus y squared. And for the third part, from y squared minus 8y, we know that we can write y minus 4 squared, and the remaining constant part, which is plus 1. Here, 4 can be written as 2 squared, and 1 can be written as 1 squared. Here, the first part can be interpreted as the distance between point x, 0 and 3, 2. Next, let us take a look at the last part of the function. This can be interpreted as the distance between point 0, y and 1, 4. And using these points, the meaning of the middle part also becomes clear. It is the distance between x, 0 and 0, y, the 2 points that are already introduced. Therefore, we can provide a geometrical interpretation of the given function using these 4 points. 2 fixed points a, 3, 2 and b, 1, 4, and 2 moving points. Point p, x, 0 that moves along the x-axis, and point q, 0, y that moves along the y-axis. Then function f represents the distance AP plus PQ plus QB. And we can find the minimum value of this distance like this. First, we draw this symmetric point A prime 3, -2 on the other side of the x-axis. And then we draw this symmetric point B prime, which is -1, 4 on the other side of y-axis. Then, since these two distances are equal and these two distances are equal, we have length of A prime P plus length of PQ plus length of QB prime. And when does this distance become minimum? Well, it is minimum when these line segments form a perfectly straight line. That is, the distance is minimum when P and Q are on line segments A prime, B prime. This also means that the minimum value of the function is simply the length of A prime, B prime, which is the square root of -1 minus 3 squared plus 4 minus -2 squared, which is square root of 52, which can be written as 2 times square root of 13. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.